Most people aren't traveling right now, but if you were heading overseas, what's the one piece of ID you always need? Your passport. It tells officials who you are, where you're from, and where you've been. Well, the COVID-19 virus also has a passport of sorts hidden in its genetic code. And right now, Canadian scientists are using that to determine how exactly it arrived here in Canada and how it spread.
As the virus moves, it changes. Things like influenza change so fast, we have to rebuild the vaccine every year. This one evolves quite slowly, but just enough that it becomes a fingerprint. So if we see two people that their virus has the same fingerprint, they probably cross-infected each other. But if the fingerprint is different, they probably did not. And we can use mathematics to work backwards to figure out how it transmitted through the community. That helps us look for weak points in infection control and population health.
In hard-hit New York City, similar research found that the bulk of its first-wave cases were linked to European travel. MacArthur says the first cases in Ontario were likely not just from the States, but from Europe, Iran, and China. He believes the genetic research will likely confirm that in the next few months. But what does all of this mean going forward?
Instead of looking retrospectively, we're going to respond immediately. So if we open up the border a bit and immediately get cases, say in the Canadian Ontario North, we can ask, is that really a community problem in there? Is this travel between Ontario, Quebec? Are these GTA people going to their cottage? Or is these tourism crossing our border? We can use the genetics to figure out these are all very different scenarios that will require different responses and change.
It would lead to a more targeted response to infection instead of the widespread shutdown we saw in the early days of the pandemic back in March. The federal government has invested $40 million into the genetic research of the virus. Half of that is going to the type of detective work MacArthur's group does, understanding the virus's genome, tracking how fast it evolves, how it travels, and whether current tests remain accurate. It also means ensuring that a potential vaccine is still effective on the virus once it's developed. The other half of the federal investment will go towards a closer look at the genetics of the people infected, understanding why some experience mild symptoms while others more severe. The project is being administered by Genome Canada. The goal is to map the genetics of every single positive case in the country, an effort that not only comes at great cost, but involves collaboration from all sectors.
I've even had a black hole physicist doing software development for me because he's very good at it, and he was at home and he had the time and he made his contribution. So it's really been a remarkable time.
The timeline for the entire project is about 2 years, but first results could come to Ontario as early as next month. In Toronto, Natividad, City News.